So I've got this board out of the V2000 Philips deck that I'm looking at, and this is a tuner board, and it connects into the various RF cans on the actual baseboard. Now, I don't think this has actually anything to do with the output of pictures from the various processing circuits to the machine itself, but I want to check it anyway, just to rule it out, because it's easy enough to get out and it's easy enough to put back in. Now, these, I found out from last time, are rather affectionately called Mullard Boiled Sweet capacitors. The colours denote the actual value of the capacitor, and I'm sure there is a list somewhere which actually gives you the actual values of these capacitors. This board is marked England because it is destined for the, well, English market. The circuit diagram that I have, which is this one, is actually for a German market machine. So if you look at the board and then compare it with the circuit diagram, some of the components are the same, but there are additional components. For example, you have this chip here. There's also on this board an additional chip here, and this is because this board also supports VHF. This board only supports UHF, so I'd say about half the components are the same, and then you have different components for the rest of it. Now, I'm going to take off a couple of these capacitors, just desolder them, and then test them, because I'd be interested to see if there are any problems with them. I am told that they are very reliable, so I doubt there will be any issues. So I'm going to start with 20, according to this we have 2001, but there's also a 2011, 2012, which isn't actually mentioned on this diagram, so it is a bit of a guessing game. 2005 is this one. That's a 3.3 microfarad, 63 volt. Looks like a smoothing capacitor. I will probably take that out of circuit because I want to test that that's okay. But I'm not sure about the others because, hang on a minute, 2006 might be this one here, but again there is nothing marked on the board, which is quite annoying actually. However, let's not worry. Let's get them out, pop them onto the tester, and see what they test out at. I'll also bring out the transistor tester as well, so we can certainly use this for testing some of those transistors. But I doubt there is actually anything wrong with this board, to be honest with you. But I'm going to try anyway, because the board is easy enough to get out. The problem that I've got is there is a lot of flickering over RF. So the picture is it's watchable, but what seems to happen after a while is the picture goes black and white, and it becomes pretty much unwatchable. There's just too much noise on the picture. It works fine over composite, but the problem is we don't have a composite interface. So we're stuck with RF unless the owner of the deck can actually find, or I can find for the owner, a actual composite interface. So I'm going to try this one in the top corner here first. May as well give that a go first off. So let's unsolder this one. It's actually taken too much effort to unsolder, so that is, that's actually the link I've just unsoldered, so I'll just resolder the link the capacitor is actually this one there, so let's quickly resolder this. There we are, and there we go. Right, grab out this one. Oh, my solder sucker has just broken. That's rather heroic. Let's see if we can fix it. Probably not. Let's see if that works. Yeah, it'll work for a bit. Right, anyway, so that should be this one out. And that comes out easily enough. So let's pop it into the tester and let's see what it's testing out at. There we go. Hmm. 459.4 nanofarads and an ESR of 5.9 ohms. Yes, okay. Let's try it with the prongs. So, there we go, let's just do that. There we are, and let's try that. .458.6 nanofarads, 6.2 ohms. That's not great, I'll be honest. Let me see if that's a common thing. Also, as an aside, they're also known as tropical fish capacitors due to the nice colours. I'm currently having a look to see if there is anything online that has a good colour code. So they're called Mullar's tropical fish capacitors. They are constructed from a metallized aluminium PET film. Dielectric material is polyethylene can't even pronounce that. Polyethylene terephthalate, which is abbreviated as PET or PETE. It is a thermoplastic polymer resin of the polyester family. Insulation resistance is 30,000 megaohms. Blimey. Temperature range -40 to +85 degrees Celsius. Let's see if we have any kind of colour coding. They are literally called Mullar's tropical fish capacitors. Right, Mullar, let's have a look online now and see if we can find anything. Capacitor colour code, colour chart, or colour code. That'll do the job. Oh, look at this. You can't see this as I'm currently looking at a computer screen. Let me turn this around and get this focused on what I'm looking at. Actually, I'll put that there. That's probably a bit better. I could use the OSB, whatever it's called, to do this. But this is what I've got so far. So let's see. Let's check vintageradio.net and see if there is anyone. So white, red. White equals 10%, red equals 250 volts, apparently. Tropical fish capacitors, much loved by the retro guitar pedal builders of today. Some more on info on the colour coding is here. Okay. So, colour codes. Similar schemes for inductors and capacitors. Okay, so let's take this one as an example. So we have yellow on the first band, so that will be, let me get a notepad up, and so yellow on the first band, that will be 4. Purple on the second band, 7. The third band is the multiplier, so times 10 to the power of 4 because it's yellow. Followed by white on the fourth band, that's the tolerance, followed by brown on the fifth band, which is the temp coefficient. So 4 times 10 to the power of 4, that should give me the value. So markings on the surface map, last digit is multiplier as above, so 100 equals 10 ohms. But it's not ohms, it's capacitance. Let's see. So I might be looking at the wrong one. So here's a tropical fish capacitor. Brown, black, yellow. 100,000 picofarads equals 100 nanofarads. So, alright, these and the single coloured cousins. So they're polyester foil. The end wires have very poor adhesion. This part is essentially scrap. Oh, that's just showing the part that's a bit knackered. Well, that one doesn't look too bad. So, brown, black, yellow. So if you did that with this colour chart up here, so brown 1, black 0, yellow times 10 to the power of 4. So let's see. Let's go for a scientific. Right, so 1, 0 times 10 to the power of 4. No, that's not right. I need to work this out. Bear with me. Okay, the colour chart seems to check out. So that means my one, so that is... Where's my notepad? Okay, so that means we're looking at 4, 7 times 10 to the power of 4. So we were measuring out at 450 nanofarads, and that would mean if we use the Google affair, so that would be 10, that would be 47 times 10 to the power of 4. 470,000 picofarads, 470 nanofarads. That seems to check out, but the ESR on that is really high. I'm going to pop it back onto the board, but I'm going to mark that one out as possibly requiring replacement. So I'll just put it back. And what does it check out? So 200. It's probably not worth actually maintaining a list on there. Let's maintain my own list. So, may as well pop it back in, because first off it means that you don't lose the component, and it takes seconds to solder it back in again. See? Literally seconds. And it's back in. But what we will do is we'll note down. So we'll have a basic drawing of the board. Like so. That should do it. So this capacitor here is 470 NF and 470 NF is yellow, purple or violet, yellow and white, and brown. Brown being the temp coefficient. So white is the tolerance, brown is the temp coefficient. Let's try this one with the orange top. So that's going to be orange of, so that's going to be orange, orange, yellow, white, and brown. So there's only 4 bands on that one. Okay, let's unsolder it and give it a test. Okay, that was rather annoying. Right, here we go. So, what's going to be this one here, I think. I need to coax that one out. Right, let's see how this one tests out. .3 nanofarads, an ESR of 10 ohms. So a bit of even further investigation suggests that these... Oh, that one's actually a bit... Oh dear, that one's going to actually need to be replaced because that's just broken off slightly. So we will need to replace that one. but a bit of further investigation suggests that they do actually produce ESRs which look quite high, but when you sort of put them into the context of what they're doing, they're actually quite low. So they are actually within tolerance. So 10 ohms and 6 ohms is absolutely fine. I'll just test this one. Yeah, the ESR on that one is now 3.2 ohms. They seem to sort of vary. It's probably because I've broken a bit of it off. So that one is 308.5 nanofarads. If I check the colour chart, orange as the first band is 3. Yellow as the second band is 4. White as the third band is, blimmin' hell, times 10 to the power of 9. Okay, that's a bit mad. So that's going to be 34 times 10 to the power of 9. So 34 times 10 to the power of 9 is a ridiculous number. 340. That can't be right, surely. No, surely that cannot be right. It wouldn't be that high. Right, let's pop that in. Although I suppose it could be that high, I don't know. Let's measure it again. So 308.4 nanofarads. Let's sort of say for argument it's around that value. 308.4 NF. I'll just put a bracket around that to replace it because it did disintegrate slightly. Right, let's try this thing here. I think it's a capacitor. It is single band there towards the back. Let's bring that out and see what that measures up at. Alright, there we are. So let's see if that's freed that one up. Yeah, it seems to have. So let's gently prise that one out. There we go. And let's stick that into the tester and see what it does. I've just pressed the wrong button. Right, so there we go. Let's see what it does. So let's do this. This one we need to replace. Put an R on that. The next one we're looking at, if we look this way round, is the capacitor that runs from there to there. So there, that's going to be, this is 1, 2, and 3. Is coming out at 11.64 microfarads, ESR of 4.9 ohms. Now I do think this one is possibly an electrolytic. It's just in a different style package, and it's a 16 volt 68 microfarad capacitor, apparently. Not sure if you can see that. Let me see. Yeah, 68 microfarads, 16 volts. That doesn't seem right, to be honest with you. That seems a little bit low for my liking. First off, we need to work out what it is. So let's do a bit of investigation. So this is actually an electrolytic capacitor, and that denotes negative, and this little dimple denotes positive. And if you remember, it was on the board like that. Now, I don't have a 68 microfarad capacitor, but I do have a 100 microfarad capacitor at 35 volts. So it's an electrolytic cap, and I'm going to pop it in place. So we've got negative towards the top, which is what it was, positive more towards the front, and we're going to pop that in. Then we can put the board back in and see what it actually does. But that's the only electrolytic on the board itself. The tropical fish ones, or boiled sweet ones, whatever we want to call them, should be okay. So let's get that soldered in. Oh, it's got bits of tissue stuck to it. That's where you normally have a sponge. So let's pop that in. There's 1, there's 2, there we go. Really doesn't look factory in the slightest, but it will do the job. So I have been advised. Soon find out if it doesn't, because it'll blow up. not the whole machine, just the capacitor will just explode. This one will need to be replaced because we are missing a nice big chunk of leg, which does sort of seem to show that these are quite fragile as they get older. So we'll probably replace like for like on that. The rest of it I'm going to leave as it is for the moment. I am tempted to unsolder one of these transistors and pop it into the tester, see how it comes out. So let's do that. Let's pick one at random. Let's try this one here. Haven't got my snippers around, so I'll just put those down there and I'll sort those out afterwards. So let's go for, which one did I say? It was this one. I want to put as little heat on these as possible. There's definite movement. Just need this one now. That should tease it out. There we go, that's out. So that is a BC548 PHP 144. Not sure if you can see that. Zoom. There you go. So let's pop it into this tester. And probably need to straighten up the legs a little bit to actually get it on. Also might need to see if I can find the little clip things. If I might be able to flatten them like that and pop it in like so. And see how it comes out. Yeah, that looks like it's doing what it should be doing. So we can pop that back into circuits, I reckon. And that's a BC548, that's a BC548, BC548. That one's different. BC548, BC548, they're mostly BC548s. So just pop this one back in, like so. There we go. And there you go, you've got your little legs come back through. So we will just pop a blob of solder onto each leg, so that's back in place. There we go. Minimal contact. There we go, so as to avoid any kind of excess heat soak, and the capacitor itself is nice and cool to the touch. So, transistor itself is nice and cool to the touch, so we haven't actually affected anything. Just like crude removal of the legs on this capacitor, which does seem to work overall. There we go. We'll also do a cursory check for dry joints. I know I did this yesterday, but I didn't pay much attention to it. Oh, one thing I will do is pop this one out. That is a 3.3 microfarad at 63 volts. So we'll get that out. That looks like it's just some kind of smoothing cap. There you go, that's what it looks like. So for this one, we will use the prongs, and we'll have to spread those quite wide, like so. And that one is giving us 3,153 nanofarads with an ESR of 18 ohms, which is about 3.3 microfarads. So that does make sense. Let's see if I've got something suitable to replace it. Short answer is no, but it does look visually undamaged, so we can probably pop that back in. I don't think it's polarised, so back in it goes. And a highish or what I would call a highish ESR in comparison to an electrolytic capacitor is probably fine on a capacitor like this. There we go, there's that, and whoops. Lovely, there we are. That's a nice finish. And just checking that that looks okay. That does look okay. We will need to replace one of those capacitors because obviously I've chunked the leg off slightly. But that electrolytic was definitely past its best. So I think next time, when I can get the machine out again, so I've put it away for the moment, just left this board out whilst I'm doing a bit of troubleshooting, I will give it a go and see what happens. Actually, I'm just going to try and prove my theory about these mains suppressor caps and ESR values. So that, yeah, that's 153.2 nanofarads apparently, so let's just pop that, let's widen those a bit, and pop that into there, like so. I should do it. Give that another test. Yeah, doesn't seem to really give me any any values of any kind of. Let's try this one. Yeah, 155.4 nanofarads, ESR 0.11 ohms. So I do wonder if there is a problem and if ESR is something to be concerned with. So I will take a look at that and do a bit of investigation. But for the moment, that's been quite an interesting little session actually, as I've had a look at the different types of capacitors that you can get in these older machines. We've learnt that these are known as boiled sweet or Mullard tropical fish capacitors. We've learnt that they're a PET or PETE type capacitor. We've also found out about the colour coding scheme that they used, and we've managed to work out some of the values of some of those caps, which has been handy. And that brings us quite nicely to the end of today's session. So I'd like to thank you all very much for taking the time to watch. I hope you have found this as interesting as I have, because it has been quite a fun little session to go through. If you've got any comments or suggestions, don't forget to leave a comment, also leave a like, and don't forget to subscribe as well. Anyway, thank you very much for watching, take care, and see you soon.